So, hello everyone, welcome to Android Study Jam Session 1. So, before we begin, I would like you to visit the link mentioned in the description below or the link that is mentioned in the chat box. So, when you visit this link, you'll notice that this is the landing page for the Android Study Jam program. You'll notice that there are two tracks here. The first track is new to programming track, and the second one is prior programming experience track. So, if you already have some experience with the programming aspects, you can directly start with the second programming track. So please note that we will only be giving certificates when you complete the second programming track, which is the prior programming experience track. So if you are to open any of the programming tracks, you'll notice that there are two units here, and each unit has some badges that can be earned upon its completion. These badges would be added to your Google developer profile. So after completion of these tracks, you will have some of the badges in your Google developer profile, and you can just send us the screenshot so that we can give you the certificate for the second programming track. So let's begin with Kotlin programming, which is the first part for our session. And yeah, okay, so before we begin, you'll find the link to the Kotlin playground in the description below. So you can either use Kotlin playground or you can either use IntelliJ IDEA. So let's start with Kotlin programming. So let's just start with a simple hello world program. So I'll just start with printing hello world as usual. So hello world. So let's run this, and you'll see that a single line is printed with hello world. It's compiling. Yeah, so the hello world is printed. You can also print on it on a single line as well. So let's say if I print hello, and I can do print and world. Let's put a space in between and let's run this. So again, hello world will be printed twice. So this was the basic hello world program. We can start with declaring data types. So in order to create variables, we use the keyword var, and we give the name for the variable, let's say var1, and we can assign it a value like 5. We can also create a variable using the val keyword, which is a read-only variable. So to equal to 20. So var2 cannot be reassigned since it is a read-only variable. If we try to reassign a different value to it, it won't work. It will give us an error changing that val cannot be reassigned. So we can also explicitly state the data type that the variable is going to be. So let's say var1 is going to be an integer, so 10. We can also leave it like this and reassign it here. Let's say 10. So there are different data types in Kotlin. So some of them are, let's say, integers. So integers, then we have strings. We also have boolean, double. So all these data types are available, and we can obviously explicitly state which variable data types these are by colon and the data type they are. So this is how we declare variables. We can assign them directly, or we can like change them in the next line. We can also create a nullable variables with the question mark after the data type. So what this means is that this variable can also hold a null value. So let's say if I do this, if object2 is let's say Android study jam, this is a string and we are placing it in the variable object2. So let's print this object2 dot let's say I'm going to print the length, so this will work. But let's say that we don't put actual string and instead we just assign it null value. So this will give us an error here. It will say that we haven't really assigned the null safety here, so we can just put a question mark. What this will do is that if the object2 is null, it will return the null value, and if it is not null, it will return us the length. So if I run this, it should print null. And let's assign something else. Let's say, yeah, this should give us 4. Yes. So this was about the nullable data types and different data types and declaring variables in Kotlin. Okay, so let's start with an example. Let's say we first accept the first name, then the last name, and display the full name. So let's try that out. So we can accept an input using the ReadLine function. Let's accept the last name and let's print the full name. So in order to format the string, we'll use the $sign and the name of the variable. So and yeah, so this will display the full name that we will be accepting. So let's run this and let's say type John Wick. So the full name John Wick will be displayed. So let's continue to some control structures. So let's declare a variable first. Let's say equal to 5, actually 7. So let's say if check1 is less than 5, we'll print less than 5. Let's put them in curly brackets actually. And let's say if object is greater than 5, we'll print it's greater than 5. So let's run this and we'll get greater than 5. So this is if else control structure. We can also use Elsev. Equal to 5. We'll display equal to 5. So this was about some control structures in Kotlin. If you want to loop through a set of statements, we can use the repeat function. So let's say repeat something 10 times and we are going to print Android study jam. So what this will do, it will print Android study jam 10 times. So another way to do this is to use a while loop. So let's remove this and let's loop it 10 times and let's print something. let's say hello Android. So what this will do is print hello Android 10 times. Yeah, so another way, another control structure is a for loop. So for, let's use the range operator in Kotlin. So this time let's print hello. You can also print I, and so what this will do is print hello Android 10 times. You can also use step. So let's step 2 times. What this will do is increment I by 2. So let's run this, and as you can see, it increments by 2. We can also use a reverse for loop. We can just do 10, and we'll use the keyword down 2 and say 0, and step by again 2. If we run this, we'll start from 10 and we'll go on decrementing by 2 and until I is 0. So this was about for loop. You can also use a when statement to it's similar to a switch statement from other programming languages. So let's try the when statement. So let's say I'm going to initialize this object variable by 10, and I can use when keyword, and let's say object is supposed to be, if it's 5, we'll print let's say it's 5. If it's 10, we can print a line, let's say it's 10. If it's neither of these, we can just simply print let's say none. And if we run this, so else is like the default case where none of these are satisfied. So as you can see, object 1 holds the value 10, so 10 is printed. Let's say if I change this to 6, we'll get none. So this was about when statement. So we can start with functions. So let's create a function that does something. So let's remove this. Let's create a function. To create a function, we use the keyword fun, and let's call it foo. Let's say this prints something. Let's say cyber 2077, and let's just call the function. So this will print cyberpunk 2077. We can also pass in some arguments. So let's say we are going to pass in some string. So let's say str, which is of type string, and what we are going to do is print the size or length of the string. So and we can pass in the same string. So let's run this. We can also return something from a function. So let's say we want to return the length of the string. So we can do this. We can do that like this. So let's return the length of the string. and let's print the same. So again 14 will be printed. Another way to do this is to use a function shorthand. So I'll just remove this, and like this way we can use a functional shorthand. So again the same 14 value will be printed. Yeah, so we can also overload functions. So to do that, let's say we are going to accept a string, and say we are going to accept an integer as well. And what we can do is return a substring of this main string. So we can use the substring function. Yeah, so let's say I'm passing in Cyberpunk 2077 and I want the first three letters of the string. So I'll run this, and this should return CYB. Yeah, so this way we can use functions and substrings associated with them. So let's try out an example for a factorial program. Let's start from scratch. So let's say we are going to accept the actual number for which we are going to calculate the factorial. So let's accept the number, and let's print the factorial. I'm going to create a function fact and pass a num to it. So let's create a function. So here we are accepting the number. We are going to return an integer as well. So here we can also use a single line if statement. So let's return. I'm going to return 1. Actually, we don't need to return here. Yeah, so let's run this, and let's enter 5. So we get the factorial 120. So let's look at let's say variable arguments. So let's create a function where we could pass in variable arguments. So I'll just remove this. I'll use the keyword var_arg so that I could have variable arguments, and let's keep the data type as string. And we can print each of the items using the function for each. So let's call this function. I'll pass in 3 names. So all the 3 names are printed. So we can also check out lists here. So let's just copy this for now. Let's create a list. So we can create a list of strings using this function list of, and we can also mention the data type. We can also create a list of primitives. So again, to iterate over this list, we can use for each. Sorry. Let's run this. So again, those three names would be printed. Okay, so one thing to note here is that the list that we created is actually an immutable list. So let's so if we check here, you can see that the list of function will return a read-only list. So we cannot change, we cannot change it, we cannot modify it, or we cannot even add elements to it. So instead of using the list of function, we can use a mutable list of function. So if I use immutable list of function, we can add more elements to it. So let's say if I do items dot add, you can add a string, and if we run this, we'll have another name, another string printed. We can also remove a string. So if I do a remove, we can remove at an index position like this, let's say at index position 1, and we can also remove a particular string that we want. So let's say we want to remove trouble. So if we run this, we should get two names, Franklin. Okay, so yeah, we should get one name, which is Franklin. So this is how we can use a mutable list, or if we want to be able to modify the list. So let's check out maps. Let's clear this. So map is basically a collection of key value pairs. So let's create it. So what we are going to do is map a string to a string. So let's say I have AB. We are going to use the keyword to, and we could type any string. Let's say string 1. Let's copy this. Let's make some more entries. Let's change the key. Okay, so we can iterate over all these values, or we can also get a particular value based upon its key. So let's create, say, str, and let's say I want the value for AB string, and let's print this. I'll run this. So we get string 1. I can change this to BC, and we'll get string 2. So what if the key does not exist in the map? Let's say I do FG. So what will happen is the null value will be returned and it will be printed. So we can use different functions also, like say get or else, and I can return something else like not in map. So if we run this, since the key does not exist in the map, we will be returned with a string, and the string will be printed. So we can also so now this map that we declared is actually an immutable map, so we can create a mutable map. So we'll use the mutable map function, and just remove this. So let's run this, and you can see we have the same output as before. And let's say we want to add a string, so we can use the put function, and you can see f, and so if you run this again, you'll see that the map is modified. We can also get the entries in a map. So to do that, we can just type in map.entries. If you want to get the keys for it, so we can do mp.keys. Let's print this on the left print line. Or we can also get the values that are present in the map. So let's run this. So as you can see, a list is returned with all the entries, then the key, we printed the keys, and then the values. So this was about the mutable map. So now let's say the key already exists in the map. Then if we just do this, let's say the key exists in the map, and if we run this, the AB key value pair will be overwritten. So if we don't want to do this, what we can do is instead of put, we can do put if absent, so that if the key is not present in the map, it will be added, and if it is present, it will not be overwritten. So if we run this, string 1 2 3 will only be the key value pairs that will be present in the map. So another thing that we can do with maps is that we can remove key value pairs based upon the keys or based upon the key and value pairs. So let's say I want to remove the key value pair AB, so I'll just use the remove function, and this should remove the AB key. So let's run this. If you want to clear this map, we can use the clear function. So we can use mp.clear, and this will clear the map of all the key value pairs. So we can also check out sets. So to do that, we can use the function setoff. Let's say it's of 1 2 3 4 5, and a set basically removes all the duplicates. So if we can look like we can input more duplicate values. So again 1 2 3 4, and we can print this. So you'll see that all the duplicates are removed. Again, this is a mutable set, so we can change this to this is actually an immutable set. We can change this to a mutable set, so we can just say mutable set of, and we can also add more elements. Let's say we add 9 to it. If we add the same elements, that is, we add duplicates, those duplicates would not be considered. So add 1. If I run this, I'll get 1 2 3 4 5 and 9. So this was about sets and mutable sets. So let's take a look at classes. So I'll just go ahead and remove this. So let's create a class person. So a class is basically just a template, and we can create different objects, different instances of it. So right now this class is not doing anything for us, so let's add some internal attributes to it, internal variables to it. So let's say fname, which is of type string, and let's initialize it to a blank string. Let's also create a last name, and also initialize it to a blank string. So we can also create a function. So let's say we want to print out the full name, so let's create a function, and we can just print the full name. So equal to so let's create an instance of this class. So we can just go ahead and create, let's say user1 equal to, we can also change these variables that we declared for this user1. So we can just say user1 dot fname equal to John, and user1 dot last name equal to Vic, and we can let's say call the function full name. So user1 dot full name. So what this will do is print out the full name. So it's compiling. Yeah, so as we can see, the full name is printed. As we can see, this class is in the same file as our main Kotlin file. So if you hover over this class word, you'll see that IntelliJ IDEA suggests us to create a new file with this class person in it. So we can just extract person from the current file to it. So what this will do is create a new file with our class in it. So this is how we can create classes and create its instances. So let's go ahead and create another function. Let's say we want to print out the length of the first name and last name. So we can just say length or length name, let's say, and let's say we are going to return an integer which is going to be the length. So we can just return fname dot length plus lname dot length, and also +1 because a space is left in between usually when we write full names. So we can also call this from our main file. So let's say print length equal to, let's say, user1 dot. So let's run this, and we should be able to see what the length is. So this is how we can create classes and call its methods. So now let's say in our class portion, we can remove these two properties and move them into a constructor as well. So if you want to do that, we can just use the keyword constructor and put these in here. So this way we can actually put these two properties into a constructor. So also we can leave them to have a default value also. So if we don't have any modifier for our constructor, so we can also remove this word constructor and it will still work. So if I run this again, the same output will be printed. So this way we can actually have constructors. We can also have multiple constructors. So to do that, let's use the keyword constructor. So and let's say we only get one string this time. So let's say we get fname, like first name. So if we receive only one string, we have to call this main constructor. So to do that, let's use the keyword this, and we pass in the string that we received as first name, and let's say unknown, that is we don't know the last name. So and we can also type in like in secondary constructor. So let's say I'll remove this. So let's copy this, and let's say this time I'll just pass in John. Change this. So let's run this. So now we can see when we called using the first object, we sent in two strings, John and Vic, and in the second object we only sent in one string, which was his first name. So this is how we can use multiple constructors in Kotlin. So let's add another variable here, let's say prefix. Let's actually remove this. And we can also send in prefix if we only get first name. So let's say none. We can also create another constructor which is going to accept first name, last name, but it does not get prefix. So let's call the main constructor. So to do this again, we'll pass in first name, last name, and we will pass in none. Actually we don't need none here. Yeah. So now what will happen is, if we only pass in the first name, this constructor would be invoked, This constructor will call this constructor because the signature matches the same as this constructor, and then this constructor will call the main constructor, which is the primary constructor. So if we go here and let's remove this as well. So let's say I'm going to just pass in John. So it's same as the second object, so I'll remove this. If I run this, I should get Mr. like, okay, so we forgot to add a prefix here, so let's add a prefix. Let's run this again, and it should give us Mr. John unknown, actually none John unknown, sorry. So this is how we can have multiple constructors. So let's look at the initializer block. So to do that, we use the keyword init, and this block is executed right after the primary constructor is called. So we can say print an init block. So if we run this, so as soon as these values are initialized, this init block is executed, and that's why we get init block first. So that was about the init block. So let's create another class. So I'll just remove this whole thing, and I'm going to call this class let's say car, and we're going to accept two properties for it. Let's say type, which is of type string, and let's accept the number of doors this car has, so which is of type int. So this was our constructor, and we can also define a method for it. Let's say display car, and we can just print the type and the number of doors this car has. So this is a class that we just declared. We're gonna also declare another class that will be inheriting from this class. So let's say class supercar, which is going to be inheriting from this car class. So to do this, we have to use the keyword open so that this class can be inherited from. So again, this car will also be accepting the type and the number of doors, and let's say it's also going to be accepting an extra property, let's say speed, which is going to be of type int. So here we can create a function unique to this, and sorry, I forgot to inherit from the car class. So to do that, we use colon and then car, and we are going to pass in these two arguments, which are type and speed. I'm sorry, doors. Yeah. So let's create a function unique to this class. So let's say display speed, and will print speed to this, and let's say let's print out this again so that we can see the variables that have been inherited from. So here let's remove this. Let's create a supercar variable, and let's say The type is sedan, and it has 4 doors, and its top speed is, let's say, 100 kilometers per hour. And what we can do is call the function display speed. If we run this, we can see that the variables been inherited, and we can see the output. So let's say if we want to create an abstract class, so first of all I'll just remove this, and let's say instead of inheriting from this class, I'm just going to declare it as an abstract class, and it is going to accept the same 2 strings as type and doors. And what we are going to do here is override this display car function. So this and use the keyword override. Yeah. And since this function is also going to be abstract, that is different types of classes that are going to extend this abstract class further are going to implement this function as well. So we'll use the keyword abstract here. So now when we create a supercar object, it will have to implement the display car function. I mean, we have already implemented it. It can use the display car function. So let's go here and change this to display car, and if we run this, we'll see the same output. So this is how we can use abstract classes in Kotlin. So this was it for this session. Please don't forget to join our Discord server. Also, we will be leaving a more detailed link for Kotlin programming, so you can visit this link, and you can learn much more detailed about Kotlin programming from there. So thank you for joining. This was Android Study Jam session 1. So in the next session, we'll be continuing with building different Android apps. So don't forget to join then. So thank you again, and